Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, we understand example 17, Algebra 7, still dealing with quadratic inequalities. And you're told to solve x squared minus 5x plus 6 is greater than or equals to 0. Keep your eye on the symbol of greater than or equals to. And because this is a region, we need now to plot the graph of y is equals to x squared minus 5x plus 6, because that is where the boundary is, or all the values of y will actually agree with specific values of x. And before we do that, when y is 0, of course we know that we'll be looking for the x-axis intercept, which are the values of x as far as this quadratic equation is concerned. So if we are solving this equation, y is equals to x squared minus 5x plus 6, then when y is 0, this equation becomes x squared minus 5x plus 6 is equals to 0. And this is what we have to solve using any method that we know. We can use factorization, quadratic formula, completing the square. Let us just easily use factorization method, because the factors which you add, they give us a minus 5, and you multiply, they give you a c. Now those are minus 2 and minus 3. So we break the middle term and have x squared minus 2x minus 3x plus 6 is equals to 0. What is common in the first two terms is x, so we can have x outside there, and then in the bracket x minus 2, and then minus 3 inside the other bracket. X 6 divided by minus 3 is minus 2, which is 0. So by all means, x minus 2, x minus 3 is 0. It means the product is 0. That means just either of the two is 0. If this is true, x can be 2, or x minus 3 can be the one which is 0. And if this is true, x is equals to positive 3. So we have realized that those are the x-axis intercept. Our graph passes through those 2 points. What about when x is equals to 0? When x is equals to 0, y becomes, when x is equals to 0, we are now looking for the y-axis intercept. Then y is equals to 0. Y is equals to 0 minus 0 plus 6. So y is equals to 6. And there we are. Let us now try to come up with a graph. And of course, we sketch the graph here, the y and x axis. What are the intercept? The intercept we have at 2, and we we can have another intercept at 3. 2 and 3. 2 and 3, that is it. And the y-intercept is when y is equals to 6. There we are. But of course, we have to know the nature of the graph. The nature of the graph means, if you, let us see, what if we took the value of x one step beyond 3, let's say 4. How will the graph behave? When x is 4, so y is equal to 16 minus 20. 16 minus 20 is minus 4, plus 6 is going to be positive 2 for that matter. And because the graph is coming from this side, then we are having a U-shaped graph, which is looking like that. The U-shaped graph, and the graph itself is y is equals to x squared minus 5x plus 6. That is our graph. Let's go back to the original question. It's talking about x squared minus 5x plus 6 is greater than 0. What is the meaning of that? Every value of y which we are interested in is greater than 0. So y is valid within that point, that region, and y is valid within that region, moving forward and moving forward. But for y to be valid within those, you can see these two lines are not continuous. They are broken region, meaning that there are two regions, each of them independent. And for this to make sense, because above that line we are talking about the positive, and below that line we know these are negative numbers, and we are interested in numbers which are greater than 0. We are interested in the value of y which is greater than 0, and we can already see from here to the left of x all the values of y are greater than 0, and from this particular point to the right of x, or to the right side of the x-axis, the values of y are positive, as you can see. That means because these two regions are independent, we cannot have a continuous equation. We can already see for this to make sense, x has to be less than 2, x has to be less than or equals to 2. And for this to make sense, x has to be greater than or equals to 3. That is exactly what we have shown and what we had to show. If you want to show this on a number line, then we are going to have something like there is a 2 there, there could be a 3 there, and let us see. X is less than or equals to negative 2 because of the presence of equality, then that could be one value of x, and x is greater than or equals to 3. The other x can occupy that region. You can already see these are two different regions, and that is the solution to that particular question. Thank you.